right, so what I want you to do for 1, A, B, and C is find all those derivatives. Find the derivatives of each of those. It should only take a second, and then we'll just talk about it real quick. Should have gotten the same thing for all of them. What did you get? Good. All of them are 4x minus 3. So where I'm headed with this is, those are all the same derivative, but did they all come from the same function? No, what's different about them? Yeah, the constant is different. All right, so the constant is different for all of them. So what we're going to do today is called an antiderivative, which is exactly what it sounds like. It's a derivative in reverse. You always have to put a plus c at the end of every single one of these to indicate that there could be plus a constant at the end, plus a 17, plus a negative 100, plus 1. All right, so it is going to be integral. And then we say f prime of x dx. It basically undoes the derivative and takes you back to the original function, so just f of x. But again, you have to put plus c at the end of every single one of them. And it's called an indefinite integral. So last time we did definite integrals, they had boundaries on them. That's the difference. They had integral from 1 to 4. And what we found was the area under the curve from 1 to 4. Here, this isn't an actual area because we don't have boundaries on the integral. It's called an indefinite integral. Do we see the difference? Definite has boundaries, indefinite does not have boundaries. And so it is an inverse of a derivative. And so what we're going to do is the derivative backwards. So when you do power rule, you multiply down the power. So you multiply, and then what do you do with that power? Power rule. You multiply down the power, and then you minus 1. Good. Subtract 1. We're going to do that in reverse. Think of like socks and shoes. You know how you take off your shoes, take off your socks, put on your socks, put on your shoes. The process gets reversed. So you're going to add 1. And then instead of multiplying, you're going to divide by that number. So before, when we did a derivative, we multiplied and then we subtracted 1. Now we're going to add 1. And process in reverse. I love doing these because we do a few and then like it starts to click and then like we end up like churning these out. Antiderivative of 0. You need to come up with a function that if you did the derivative, you would get 0. It's like 0 is the answer. It's a Jeopardy thing. You're going backwards. So what's a function that if you did the derivative, 0 would be the answer? 5 or 2 or 12 or 17 or negative 4 million. So in other words, what? C, a constant, any constant. So this one, you need a function that if you did the derivative, you would get negative 3. So like negative 3 is the answer. Good, negative 3x and then plus c. Every single one of these is going to have a plus c at the end. All right, how about this one? You need a function that if you did the derivative, you would get 5. 5x plus c. And you can always check these by doing the derivative. You would get 5. All right, now I threw a variable in there. So think about the x. You want to raise the power. So this is really x to the first. We're going to add 1 to that. It would be x to the second. And then you want to divide by 2. So out front, you would have a 1/2. Some people like to write it like this. It means the exact same thing, and it is totally your personal preference. I like to just put the 1/2 as a coefficient. That's my personal preference, but these mean the exact same thing. So however you want to write it is fine. All right, and then plus, because we've got that 10 there, it'll be plus 10x plus c. Good. All right, so again, you want to add 1 to the power. Oh, whoops. I was trying to darken that up. I didn't want to zoom in. So right now it's to the third. It would be to the fourth. And then you want to divide by 4. So you can either just put the whole thing over 4, or I like to put a 1/4 out front. Again, that's up to you. Plus c. Now, this one has a 1/3 out front. What I would do is ignore that. What would it be for the x to the 5th? What would that antiderivative be? It's to the 5th right now, so it changed to x to the 6th, and then you'd have a 1/6 out front. But there's already a 1/3. Good, so it would be 1/18, and then plus c. So kind of like just ignore the coefficient, and then you can put it back. All right, what do you guys think for this one? You need a function that if you did the derivative, this would be your answer. Good, plus c, perfect. X to the 3rd, that would give you 3x squared. 2x squared, that would give you 4x, and then plus a constant. All right, here comes the trig. You need to come up with a trig function that if you did the derivative, you would get sine. Sine's the answer. Good, it is negative cosine plus c. Because derivative, if you didn't put that negative there, derivative of cosine would be negative sine, but it's a positive sign, so you need the negative there to cancel it out. All right, this one's secant tangent. Which trig function has secant tangent as its derivative? Like that's the answer. Good. Derivative of secant is secant tangent. And then for this one, which trig function has cosecant squared as its derivative? And I'll give you a hint, we will need a negative for this because it's technically negative cosecant squared. Which one? Good, cotangent plus c of x, yes, good. You always need a variable there. Derivative of cotangent is negative cosecant squared, so that's why we needed the negative there. All right, and here's everybody's favorite, e to the x. E to the x is its own derivative, so it is its own antiderivative. Isn't that fantastic? So this would just be what? Yeah, 15 e to the x plus c. All right, and then what about this one? Good, 1/5 x to the 5th. Yep, minus e to the x plus c. 1 over x. You need a function that if you did the derivative, you would get 1 over x. Like 1 over x is the answer. Good. Now, when you do this, you need an absolute value around the x. The reason for that is, this is your ln graph, just to remind you. You cannot ln negative numbers. That is not part of the domain. You can only natural log, any log, positive values. So that's why we put the absolute value there to ensure that that's positive, because the domain is only positive values. This one, that 3 always ends up throwing people off. If you want to think of this as a 1/3, you can kind of like evict the 1/3 from the problem and think of it that way. You can never kick a variable out, but you can take a coefficient and kick it out of the integral, and that kind of makes it easier because this part would just be ln, and so it's 1/3 ln of x plus c. I never say absolute value when I'm saying it because it's just a mouthful, but it's always there. And let me go ahead and pause for a second because the screen, this is still showing up, but the screen on my computer went black. So you know what I'm going to do? I'm going to hit end so that my recording